I would like to explain that that every normal subgroup is the kernel of a homomorphism. That means to say that a normal subgroup is a group in which you can put any member of the set A in front of the subgroup, or put it in back, and the answer comes out the exact same thing. It comes out to be the subgroup. We'll call that N. And to see that the kernel, that the subgroup N is the kernel of a homomorphism, well, first we have to describe a type of map that leads from the general group G to the quotient group G over N, which is just the set of all of the cosets of the elements of G times N. And that's called that type of map that goes from G to the quotient group is called a canonical map or a natural map. And that map we know is a homomorphism, because if we would take, like, let's say we'll call that map pi, we'll call it pi of AB. Well, since it's a map which goes to the quotient group G over N, that means that AB is going to go to, by pi, by the action of pi on it, it's going to become ABN, which is the same thing as ANBN, because N is the identity of the normal subgroup, has that quality of being an identity. And so you can multiply it times itself any number of times you want, you'll come out with the same. And so ABN equals the same thing as AN times BN, and that's equal to pi of A times pi of B. So we see that pi is a homomorphism, and the kernel of pi is the kernel of any type of function, is that if you take whatever function it's coming from, and it all goes to 1, or the identity. And so we know the kernel of pi is the set of all A, such that if you would take any of A, you would come out with N. So therefore the kernel of pi is equal to N.